Hello and welcome to this quiet hour of celestial imagination, where we'll drift through an alternate universe, one where humanity's eyes open to the stars much sooner. If you're here with weary eyes, a busy mind, or simply a love for cosmic daydreams, you've found the perfect corner of the cosmos to rest. Tonight, we're embarking on a gentle thought experiment. What if the Hubble Space Telescope had been invented 50 years earlier? Picture a world where, instead of the 1990s, those first breathtaking images of distant galaxies arrived in the 1940s, a time of war and radio static suddenly interrupted by the silent poetry of spiral nebulae and star clusters. How might those early glimpses of cosmic grandeur have reshaped science, culture, and our very sense of place in the universe? Before we begin, I'd love to know, where does your mind wander when you think of the stars? Are you someone who gazes up at night, tracing constellations, or do you prefer to explore the cosmos from the cozy darkness of your room? Wherever you are, whatever your ceiling looks like tonight, I'm glad you've joined for this journey through time and space. Take a slow breath in and out. Let the hum of the present fade as we slip into this alternate past, where a gleaming telescope orbits Earth decades ahead of schedule, its lens capturing light that had traveled billions of years just to meet us sooner. Let your thoughts soften like starlight in dawn's first glow as we begin. In this imagined world, the Hubble isn't just a machine, it's a time capsule, a silent witness to cosmic history, and perhaps a key that unlocked humanity's cosmic awakening much earlier than we ever thought possible. So close your eyes if you'd like, or let them rest half open like the shutter of an old camera, as we drift back to the 1940s when the universe was still a blurry mystery and one brilliant invention might have changed everything. Drifting back through time, not just years, but decades, to an era when the world was on the brink of transformation. The year is 1940. The skies above Earth are still untouched by human-made stars, and the greatest telescopes of the age are bound to the ground, their views blurred by the restless atmosphere. Now, picture something impossible for that time. A delicate, silvered eye floating high above the planet, unshackled from the haze of air and clouds, gazing deeper into the cosmos than anyone had ever dreamed possible. This is the Hubble Space Telescope, but not as we know it. This Hubble belongs to an alternate history, one where it was conceived and launched 50 years earlier, in an age of propeller planes and vacuum tube radios. In this quiet reverie, let us unfold what such a reality might have been like. The Hubble of the 1940s would have been a triumph of ingenuity, a masterpiece of mirrors and mechanics crafted without the benefit of microchips or modern materials. Its design would have been simpler, its capabilities more limited, and yet its core purpose unchanged. It would have been a window, a fragile portal through which humanity could peer beyond the confines of our atmosphere and into the depths of space. Think of the astronomers of that era, hunched over photographic plates in dimly lit observatories, squinting at smudges of light that might be distant galaxies. Now imagine their wonder if, instead of struggling against the distortions of Earth's air, they could study images crisp and clear, delivered from a telescope riding the silent currents of space. The universe it would have revealed was no different than the one we know today. The same ancient rite, the same swirling nebulae, the same galaxies drifting like ships on an endless sea. But the impact of seeing them so soon, so clearly, would have been profound. In our own timeline, Edwin Hubble himself, the man for whom the telescope would later be named, was only just uncovering evidence that the Milky Way was not alone, that those faint spirals in the sky were entire islands of stars, unimaginably distant. What if instead of relying on ground-based observations, he had access to a telescope above the atmosphere, one that could see farther and sharper than anything on Earth? The revelation of an expanding universe, the discovery of quasars, the first glimpses of galactic collisions, all of these might have come decades earlier, rewriting textbooks before most of the world had even seen a television. And yet, the challenges of such an endeavor would have been immense. The rockets of the 1940s were crude things, barely able to reach the edge of space, let alone carry a delicate observatory into orbit. The materials available then, thick glass for mirrors, heavy metals for structures, would have made Hubble a far more cumbersome machine than the sleek instrument we know today. There would have been no space shuttle to repair it, no digital sensors to capture its images, only slow and patient work by engineers who had never even dreamed of a microchip. But perhaps, with enough determination, with the right minds converging at the right moment, it could have been done. After all, the atomic bomb was built in this same decade, a project of unimaginable complexity and scale. If humanity could split the atom in the 1940s, why not also build a telescope to touch the heavens? Now, let us linger in this thought a little longer. Picture the first images returning to Earth, not as digital signals, but as carefully developed film canisters parachuting down from orbit to be analyzed by scientists in wool suits and round spectacles. Imagine the headlines in newspapers, the hushed discussions in lecture halls, the sudden, staggering realization that the universe was vaster and more mysterious than anyone had guessed. The night sky, once a familiar friend, would have become something else entirely, a doorway, an abyss, a mirror reflecting back the enormity of time itself. This, then, is where our journey begins. Not with a roar of rockets, but with a slow, quiet unfurling of possibility. A telescope in the sky, before the first satellite, before the first astronaut, before humanity truly understood what lay beyond a blue. In the stillness of space, it would have waited, patient as the stars themselves, ready to show us wonders we were not yet prepared to see. Now, let us gently pull back the veil of time a little further to the moment when this grand idea might have first taken shape. Not in the bustling, computer-filled halls of NASA in the 1980s, but in the quiet, wood-paneled offices of astronomers and engineers in the 1930s and 40s. The concept of a space telescope would have been audacious, almost unthinkable, in an era when the very notion of launching anything into orbit was still the stuff of science fiction. Yet the seeds of such a vision were already there, scattered like stardust in the minds of a few forward-thinking dreamers. Picture for a moment the great observatories of that age. Mount Wilson, where Edwin Hubble himself worked, its massive dome housing a telescope that was, for its time, a marvel of engineering. Astronomers would spend frigid nights guiding the instrument by hand, peering through eyepieces, their breath visible in the cold air as they meticulously recorded their observations in leather-bound notebooks. The idea of placing a telescope beyond the Earth's atmosphere would have seemed like madness, or brilliance. Perhaps it was both. The first whispers of such a project might have come from the same minds that were then grappling with rocketry. In Germany, Wernher von Braun and his team were already laying the groundwork for the V-2 rocket, a weapon of war that would, in another timeline, become the precursor to space exploration. What if, instead of destruction, some of those resources had been turned toward the stars? Imagine a small group of astronomers and engineers gathered around a chalkboard in some dimly lit room, sketching out the rough design of a telescope that could be lifted above the atmosphere. The calculations would have been daunting. The mirror alone, made of thick glass, would have weighed far more than modern materials allow. The optics would have required painstaking hand polishing, a craft as much art as science. And the means to stabilize the telescope in orbit, to point it with precision, would have demanded innovations that bordered on the miraculous. Yet the desire to see farther, to know more, has always driven humanity to attempt the impossible. The astronomers of that era were no different. They had already transformed our understanding of the cosmos with the tools they had. Edwin Hubble's revelation that the universe was expanding, that the nebulae were in fact other galaxies, had shaken the foundations of science. What if he had been able to point to a photograph taken from space showing the crisp, unmistakable spiral arms of Andromeda free from the blurring of Earth's atmosphere? The evidence would have been undeniable, the impact immeasurable. And so, in this alternate history, the project begins. It would have been a fragile thing, this early Hubble. Its mirror smaller, its structure heavier, its lifespan shorter. Without the advanced alloys and composites of the later 20th century, it would have been a feat of sheer determination. The launch itself would have been a perilous undertaking. The rockets of the 1940s were unreliable, their trajectories uncertain. The telescope might have been placed in a low, unstable orbit, its instruments slowly succumbing to the harsh environment of space. But none of that would have dimmed the awe of those first images. Think of the moment when the first photographs arrived back on Earth. They would have been grainy, perhaps, limited by the technology of the time, but they would have revealed details no one had ever seen before. The craters of the moon, sharp and clear, without the distortion of the atmosphere. The bands of Jupiter, swirling in intricate patterns. The rings of Saturn, their delicate structure, visible for the first time. And beyond our solar system, the faint smudges of distant galaxies, their shapes unmistakable. The scientific community would have been electrified. The public, too, would have been captivated. In an era still reeling from war, the sight of the universe in such clarity might have offered something profound, a reminder of humanity's small place in a vast, beautiful cosmos. But the challenges would not have ended there. Without modern communication systems, data from the telescope would have been slow to transmit, painstakingly collected and analyzed. Engineers would have had to devise ways to repair or adjust the telescope remotely, with no hope of a servicing mission. Yet, for all its limitations, this early Hubble would have been a beacon, a proof that the stars were not beyond our reach. As we drift through this thought experiment, let us pause to reflect on what such an achievement would have meant. The space age, in our timeline, began with Sputnik in 1957, a simple beeping satellite that stunned the world. But in this alternate history, the first human object in space might have been a telescope, a silent observer of the cosmos. The trajectory of exploration would have been altered, perhaps accelerating our journey into space or diverting it in ways we can only imagine. And so, as we prepare to delve deeper into the wonders this early Hubble might have uncovered, let us hold in our minds the image of that fragile, brilliant machine floating alone in the darkness, its lens open to the universe. It would have been a solitary pioneer, a whisper of what was to come, a testament to the enduring human desire to see beyond the horizon, to know the unknowable. As we drift deeper into this alternate history, to the moment when humanity's first space telescope opened its eye to the universe, in our imagined 1940s, this would have been called first light, that sacred astronomical term marking when a new instrument captures its inaugural photons from the cosmos. Picture a hushed room filled with men in crisp suits and women in wool skirts, all gathered around a grainy projection screen in some government laboratory. The images arriving would have been transmitted via radio waves, slowly building line by line on photographic plates, each new detail emerging like a ghost from the void. The first target would likely have been something familiar, perhaps the moon, its cratered face appearing with startling clarity, each ridge and valley standing in sharp relief without atmospheric distortion. Scientists would have gasped at features never before seen: tiny craterlets within larger basins, delicate fractures in the lunar crust, the precise edges of shadows cast by mountains. Where ground telescopes showed a blurry sphere, this spaceborne eye revealed a world. Next might have come Jupiter, its cloud bands so crisp that individual storms could be tracked, the great red spot appearing not as a smudge but as a distinct swirling vortex. Saturn's rings would have unveiled their mysterious divisions, the Cassini gap appearing as a clean, dark line through the glittering disk. This single image might have settled the great debate over the nature of nebulae years before it happened in our timeline. Astronomers would have suddenly held proof that our Milky Way was just one of countless galaxies adrift in an immeasurable void. The philosophical shockwaves would have rippled far beyond astronomy. Theologians, artists, and poets would have grappled with this new cosmic perspective at the height of World War II, creating a fascinating cultural juxtaposition. The technical limitations of this early Hubble would have created their own poetry. Without modern CCD sensors, each image would have required long exposures on glass plates, specially designed to withstand the space environment. Engineers might have devised a system where exposed plates were periodically jettisoned in small capsules to parachute back to Earth, a celestial message in a bottle carrying cosmic secrets. Imagine teams of scientists scouring remote drop zones, racing to recover these precious plates before their emulsion degraded, treating each recovered image like religious artifacts. The delays between observation and analysis would have created a slow, contemplative pace to discovery, each new finding marinated in thought before being shared with the world. This telescope's limited lifespan, perhaps just a few years before its systems failed, would have lent each observation profound urgency and weight. Every target chosen would represent a difficult decision about how best to use this fleeting window into the cosmos. The final images might have taken on an elegiac quality, as astronomers realized they were seeing further than humans ever had before, yet knowing how much more remained unseen. When the last transmission's static-filled signal finally ceased, it would have marked not an end, but the beginning of humanity's eternal reach toward the stars. The quiet revolution unfolding in the years after that first miraculous glimpse of the cosmos, the early Hubble, though primitive by our standards, would have begun whispering secrets of the universe to earthbound scientists in a language of light and shadow. Each photographic plate recovered from its orbital drop capsules would have been like receiving a letter from the edge of time itself, penned in the delicate handwriting of photons that had traveled millions, sometimes billions of years to reach us. Picture the observatories of this era, their domes dark against twilight skies, their floors creaking under the weight of ponderous telescopes, now suddenly playing second fiddle to this new eye in the heavens. Astronomers who had spent their careers squinting through eyepieces would gather in hushed libraries, passing around the space telescope's images like sacred texts. The glass plates would still carry the faint scent of developer chemicals as researchers traced spiral arms with their fingertips, following the graceful curves of galaxies that no human eye had ever seen so clearly. There would have been a sacred quality to these viewing sessions, conducted under dim red lights to preserve the plate's delicate emulsions, where even the most hardened scientists might find themselves pausing to simply marvel at what they were seeing. The scientific revelations would have come slowly, gently, like dawn creeping across a landscape. Without modern computers to quickly analyze data, each discovery would have required patient contemplation. A researcher might spend weeks measuring the positions of variable stars in a single galaxy plate, plotting their brightness changes on graph paper with a sharpened pencil. The cosmic distance ladder, our method for measuring the vast gulfs between galaxies, would have been built painstakingly by hand, calculation by calculation, logarithm tables spread across wide wooden desks. This slow pace of discovery might have been a gift in disguise, allowing each new understanding to settle deeply into the scientific consciousness before being overtaken by the next breakthrough. Consider how differently we might have come to understand stellar life cycles in this timeline. The great nebulas, Orion, Eagle, and Carina, would have revealed their stellar nurseries with unprecedented clarity decades earlier than in our reality. Astronomers would have watched season after season as new stars flickered to life within these cosmic clouds, their light slowly burning away the surrounding gas like morning mist under sunlight. The death of stars, too, would have appeared in shocking detail. Supernova remnants like the Crab Nebula showing their intricate filamentary structures, planetary nebulae displaying their delicate symmetrical shells ejected by dying suns. These observations might have inspired entirely new schools of artistic representation as painters and photographers struggled to capture these newly revealed cosmic landscapes. The cultural impact would have rippled outward in gentle waves. In an era before television dominated popular culture, these cosmic images would have circulated through newspapers and magazines, their captions filled with a sense of awe that modern audiences might find quaint. Planetariums, then relatively new institutions, would have rushed to update their shows with these stunning visuals, their domes filled with gasps as audiences saw the heavens unveiled. Poets like T.S. Eliot or W.H. Auden might have penned verses about the eye among the blind stars, while composers like Shostakovich or Copland could have been inspired to create symphonic works echoing the vastness of space. Even fashion would have felt the influence, with evening gowns mimicking spiral galaxies and jewelry taking inspiration from Hubble's crisp images of star clusters. Yet for all these revelations, the telescope's greatest gift might have been the questions it raised. Each answered mystery would have revealed deeper puzzles waiting in the cosmic dark. Why did galaxies arrange themselves in vast filaments and walls? What powered the unimaginably bright quasars glimpsed at the edge of visibility? How did the universe begin? These questions would have haunted the dreams of scientists and laypeople alike, floating in the collective imagination like half-remembered dreams. The early Hubble would have shown us not just how much we could see, but how much remained unseen. A humbling realization that might have softened some of the century's harsher ideologies with its quiet perspective. As we imagine this alternate history unfolding, let us pause to consider the telescope itself. Alone in the cold vacuum, its metal skin expanding and contracting with each pass into sunlight, its mechanisms slowly wearing down even as it revealed undreamed-of wonders. There's a melancholy beauty to its solitude, this human-made star watching over us as we slept unaware below. In its final days, as its systems began to fail one by one, it might have turned its faltering gaze toward Earth, capturing one last image of our blue-white marble floating in blackness, a farewell portrait that would have brought tears to the eyes of even the most stoic researchers when it finally made its way back to the planet it had so faithfully served. As the years unfolded in this alternate timeline, the presence of Hubble's eye in the sky would have quietly reshaped not just astronomy, but the very fabric of human thought. Imagine the mid-1950s, a world rebuilding from war, now suddenly gifted with cosmic perspective. The telescope's continuous stream of images, each plate more breathtaking than the last, would have created a slow-motion revolution, seeping into laboratories and living rooms alike, like dawn's first light gradually illuminating a sleeping landscape. The scientific breakthroughs would have arrived like gentle waves lapping at the shore of understanding. Without digital sensors, but armed with these unprecedented views, astronomers would have developed ingenious analog techniques to extract knowledge from the glass plates. They might have used delicate hairline micrometers to measure distances between stars, or constructed elaborate light tables where multiple plates could be compared under magnifying glasses to detect the subtle, proper motions of celestial objects. The variable stars in distant galaxies, those cosmic lighthouses allowing us to measure the vast intergalactic distances, would have been cataloged with painstaking precision by teams of computers, humankind, mostly women working with pencil and paper in quiet rooms filled with tobacco smoke and the soft scratching of nibs on graph paper. This early cosmic perspective might have influenced physics in profound ways. Einstein's relativity, still fresh in academic circles, would have found spectacular confirmation in Hubble's ability to observe gravitational lensing, the bending of light around massive objects decades before it was confirmed in our timeline. The expanding universe, which in our history took decades to become accepted doctrine, might have been established fact by the 1950s in this alternate world. Quantum physicists, puzzling over the strange behavior of atoms, would have had before them daily reminders of quantum processes scaled up to cosmic proportions, the very fusion reactions they sought to understand visibly powering the stars in Hubble's crisp images. The philosophical implications would have been equally profound. Existentialist thinkers like Sartre and Camus, writing in post-war Paris cafes, might have found their meditations on human meaning transformed by the knowledge that thousands of galaxies, each with billions of stars, were now visibly confirmed to exist. The pale blue dot perspective, which in our timeline came with Voyager's 1990s photograph, would have been part of cultural consciousness since the Truman administration. Religious leaders across faiths would have grappled with these cosmic visions, some seeing divine handiwork in the newly revealed grandeur, others finding their doctrines needing expansion to encompass a universe vaster than any sacred text had ever imagined. Consider how differently space exploration might have developed with these images available from the start. The early rocket engineers, von Braun, Korolev, and their teams, would have had before them crystal-clear photographs of the moon's surface as they planned their first lunar probes. The Apollo program, when it came, might have been driven less by Cold War competition and more by a matured cosmic perspective, with astronauts seeing themselves not just as national representatives, but as ambassadors of Earth. That iconic Earthrise photo from Apollo 8 would have been anticipated by decades in the public imagination, thanks to Hubble's earlier portraits of our fragile world suspended in the void. The arts would have bloomed with cosmic inspiration in this timeline. Abstract expressionists like Pollock might have found new motifs in Hubble's images of chaotic star-forming regions. Science fiction literature, then in its golden age, would have been grounded in real cosmic vistas rather than speculative imaginings. Ray Bradbury's Martian Chronicles might have been illustrated with actual photographs of the red planet's surface. Stanley Kubrick's 2001 A Space Odyssey, when made, could have drawn on 30 years of public familiarity with deep space imagery, creating an even more immersive experience. Yet, perhaps the most beautiful aspect of this alternate history would have been the telescope's inevitable aging. As the 1960s dawned, our hypothetical early Hubble would have been showing its years, its gyroscopes drifting, its mirror coatings degrading, its once precise pointing becoming erratic. But like a revered elder sharing final wisdom, it would have continued gifting us insights until its last operational day. The final images might have been blurrier, the transmissions fainter, but no less precious for their imperfections. When at last its signals ceased, the worldwide mourning would have been tempered by gratitude, for this mechanical ambassador had given humanity its first true vision of the cosmic ocean in which we float. And so, as we continue drifting through this thought experiment, we find ourselves at a crossroads in our imagined timeline, the late 1960s, when the lessons from this early Hubble would have been shaping plans for its successors. The scientific community, now addicted to the clarity of space-based observation, would have been planning bigger, better telescopes even as they continued mining the treasure trove of data from their first celestial sentinel. The public, having grown up with these cosmic visions, would have regarded space not as a frontier to conquer, but as a cathedral to contemplate, changing in subtle ways our entire approach to exploration. As our imagined timeline drifts into the 1970s, the impact of this early Hubble would have settled into the bones of human civilization like stardust gently falling through the cosmic dark. The telescope itself may have gone silent by now, its metal husk still circling the Earth in a slow, decaying orbit. an artificial moon turned relic of human curiosity. But its legacy would live on in countless unexpected ways, shaping not just how we saw the universe, but how we saw ourselves within it. The children of this alternate 1970s, growing up in a world where crisp images of galaxies had always existed in their textbooks. For them, the vastness of space wouldn't be an abstract concept learned later in life, but a fundamental truth absorbed as naturally as the blue of the sky. Elementary school classrooms might have featured glowing orreries showing not just our solar system, but the local galactic neighborhood with tiny Andromeda and Triangulum galaxies suspended across from a spinning Milky Way. The overview effect, that profound shift in awareness experienced by astronauts seeing Earth from space, would have been part of the cultural consciousness from childhood, long before the first human left the atmosphere. The scientific harvest from those early decades of space observation would have been staggering. With 30 years of deep space imagery to study, astronomers might have identified dark matter's gravitational effects far earlier, noticing how galaxies moved in ways that couldn't be explained by visible mass alone. The cosmic microwave background radiation, that faint echo of the Big Bang discovered in 1964 in our timeline, would have been sought more deliberately and found sooner as researchers armed with Hubble's deep field imagery theorized about the universe's origins. Exoplanet research, which in our history didn't begin yielding results until the 1990s, might have started in earnest during the Apollo era as astronomers scrutinized Hubble's decades of stellar photographs for the telltale wobbles of unseen planets. Technology would have evolved differently under the influence of this early cosmic perspective. The challenge of processing thousands of delicate glass plates might have accelerated the development of computers earlier than in our timeline. The need to share these celestial images across continents could have driven innovations in global communication networks, a proto-internet created not for military purposes, but for scientific collaboration. Photographic technology would have advanced rapidly to meet astronomers' demands, meaning your grandfather's vintage camera in this alternate world might have boasted resolution capabilities ours didn't achieve until digital sensors arrived. The environmental movement might have found its most potent symbol in Hubble's images of Earth, a fragile blue oasis in the cosmic dark. That iconic blue marble photo taken by Apollo 17 in 1972 wouldn't have been shocking in this timeline, but rather a confirmation of what people had seen for decades in Hubble's regular portraits of our planet. The first Earth Day might have happened earlier with greater urgency as generations raised on cosmic perspective confronted pollution and ecological damage. Cultural touchstones would resonate differently. Star Trek's "To Go Boldly Go" might have carried more philosophical weight, less imperialistic undertones. Pink Floyd's Dark Side of the Moon could have been a multimedia experience featuring actual Hubble imagery. The psychedelic movement might have drawn less on abstract internal visions and more on the very real cosmic vistas now available to all, a different kind of expansion of consciousness. And what of the night sky itself? With Hubble's revelations so deeply embedded in culture, amateur astronomy would have flourished earlier. Backyard telescopes might have been as common as bicycles, with families gathering on summer nights not just to look at the moon or planets, but to find the smudges of distant galaxies with their own eyes, knowing exactly what magnificent structures those faint lights represented. The Milky Way, when visible away from city lights, wouldn't be just a beautiful band. It would be understood as the edge-on view of our galactic home, with countless other such islands floating in the deep. As we near the end of this particular reverie, let us imagine the final resting place of our hypothetical early Hubble. Unlike our real Hubble, which will be carefully deorbited when its mission ends, this 1940s-era telescope would likely have met a more poetic fate, its orbit gradually decaying over decades until one day, friction with the upper atmosphere finally pulled it home. Picture it streaking across some twilight sky as a brilliant fireball, perhaps over the Pacific, where no one would witness its final moments. Its components, forged in an era of war, would vaporize into particles that once had formed stars. a perfect circle completed. Yet its legacy would remain in the scientists it inspired, the artists it moved, the ordinary people who saw themselves differently because of its images. The later space telescopes that followed, bigger, more powerful, would all owe their existence to that first brave eye in the sky. And though its technology would seem laughably primitive by modern standards, there would be something undeniably moving about its humble beginnings, its grainy first images, its proof that even in humanity's darkest hours, we still looked upward with wonder. So close your eyes now, rest well, and somewhere in the cosmic dark, perhaps there still drifts some version of that first telescope, its lens open to eternity, watching over our dreams. Further into the 1970s, the early Hubble's legacy would have blossomed into a full-fledged golden age of cosmic discovery, one where humanity's understanding of the universe expanded not in sudden leaps, but in a gradual dawning realization, like morning light slowly revealing a vast and intricate landscape. The world would have by now taken for granted what had once been unimaginable: crystal clear views of the cosmos unobstructed by Earth's turbulent atmosphere. Yet the true revolution was only beginning, as scientists stood poised on the brink of even greater revelations, like sailors who had mapped the shoreline, now preparing to venture into the open ocean. The scientific method itself would have evolved under this prolonged exposure to cosmic clarity. An entire generation of astronomers would have been trained not on the blurry photographic plates from ground-based telescopes that the predecessors struggled with, but on Hubble's pristine images of spiral galaxies, glowing nebulae, and star clusters. Their very intuition for galactic structures, stellar evolution, and cosmic distances would have developed differently. Where scientists of the 1940s might have spent entire careers painstakingly proving the existence of other galaxies, these new researchers would think naturally in terms of galactic clusters and superclusters, their mental maps of the universe containing orders of magnitude more detail than any previous generation had possessed. This shift in perspective would have extended far beyond academic circles. The public's relationship with the cosmos would have deepened in subtle but profound ways. Planetariums, once rare attractions found only in major cities, might have become as common as public libraries. Small, local domes where communities gathered regularly to see the latest images from space. Evening news programs could have featured regular cosmic update segments where avuncular science correspondents explained new discoveries while showing breathtaking visuals that would have been classified research material in our timeline. Children's lunchboxes, bedroom walls, and school notebooks would have displayed accurate depictions of the Orion Nebula or Andromeda Galaxy rather than cartoonish flying saucers, making the real universe a constant presence in young minds. The arts would have absorbed this cosmic perspective in fascinating ways. Abstract expressionists like Jackson Pollock might have found new inspiration in Hubble's images of chaotic star-forming regions, their canvases echoing the fractal beauty of stellar nurseries. The minimalist movement could have taken cues from the stark elegance of planetary orbits or the perfect geometry of galactic rotation curves. Science fiction literature, then in its golden age, would have been grounded in real cosmic vistas rather than pure speculation. Imagine Ray Bradbury's The Martian Chronicles illustrated with actual photographs of the red planet's surface, or Arthur C. Clarke's stories referencing real exoplanetary systems rather than invented ones. The philosophical impact would have been equally profound. Existentialist thinkers wrestling with questions of meaning in a post-war world would have done so against the backdrop of confirmed galactic superclusters stretching beyond imagination. Theologians across faiths would have held symposiums on reconciling ancient scriptures with this new cosmic reality. Even popular culture would have reflected this shift. Late-night talk show hosts might have peppered their monologues with jokes about galactic redshifts, knowing their audiences would get the references. Technologically, the challenges of maintaining and improving space-based astronomy would have driven innovations decades ahead of our timeline. The need to process millions of stellar images might have accelerated the development of early computing technology, with observatories housing room-sized machines dedicated solely to astronomical calculations. The precision required for telescope mirrors could have pushed materials science forward, leading to earlier developments in fiber optics or laser technology. Even our daily lives might have been different. Perhaps the CCD sensor in your smartphone camera would trace its lineage directly to innovations created to replace those delicate glass plates used by the early Hubble. Environmental awareness might have taken root earlier and more deeply in this timeline. The iconic blue marble image of Earth, which in our history shocked the world in 1972, would have been preceded by decades of similar images from Hubble, creating a long-standing cultural awareness of our planet's fragility. The environmental movement could have gained scientific credibility earlier by aligning itself with astronomers who spent their careers studying other worlds. Men and women who could testify firsthand to the uniqueness of Earth's biosphere when seen against the cosmic backdrop. As we leave this moment in our imagined timeline, poised at the peak of the first great era of space observation, we can see how the simple act of placing a telescope above the atmosphere 50 years early would have changed not just science, but the entire trajectory of human culture. The universe would have ceased to be an abstraction and become instead a familiar landscape, its wonders as much a part of common knowledge as the oceans or continents. And this, perhaps, would have been the early Hubble's greatest gift. Not any single discovery, but the gradual, generation-long cultivation of cosmic perspective, the quiet understanding that we are but one small piece of an astonishingly vast and beautiful whole. As the 1980s dawned in this alternate timeline, the scientific landscape would have transformed in ways almost unimaginable in our own history. The Hubble telescope, now operating for nearly 40 years, would have ceased being a mere instrument and become something far more profound. Humanity's first true laboratory for studying universal laws at cosmic scales. Where traditional laboratories confined experiments to tabletops, this orbital observatory allowed researchers to test fundamental physics against the grand canvas of the universe itself. The field of cosmology would have evolved along dramatically different lines. With access to clear, space-based observations since the 1940s, scientists might have developed more sophisticated models of cosmic expansion much earlier than our timeline. The Hubble constant, that critical number describing how fast the universe grows, could have been calculated with greater precision decades before our timeline, leading to earlier recognition of the accelerating expansion that won the 2011 Nobel Prize in our reality. General relativity, rather than being confirmed through occasional solar eclipses, would have been constantly tested against the gravitational lensing effects Hubble observed in distant galaxy clusters. Particle physics might have taken a different trajectory as well. The extreme conditions observed in neutron stars and active galactic nuclei would have provided natural laboratories for studying matter under pressures and temperatures impossible to recreate on Earth. Theorists could have predicted quark-gluon plasma and other exotic states of matter years earlier based on these cosmic observations. The search for dark matter particles might have begun in earnest during the 1970s in this timeline, as astronomers accumulated overwhelming evidence of missing mass from decades of galactic rotation curves. The technological spin-offs from maintaining this early space observatory would have revolutionized multiple industries. The need for ultra-pure mirror coatings resistant to decades of space radiation might have driven innovations in material science that later found applications in everything from medical implants to renewable energy. The precision pointing systems developed to keep Hubble steady for long exposures could have led to earlier advances in robotics and guidance systems. Even the humble CCD sensor in your smartphone camera might have traced its lineage directly to innovations created to replace those delicate glass plates used by the early Hubble. Education systems worldwide would have been fundamentally reshaped by this prolonged cosmic enlightenment. High school science curricula might have included mandatory courses in comparative planetology by the 1970s. University astronomy departments could have required students to be proficient in both telescope operation and computer programming from the outset, creating a generation of computational astronomers decades before the term existed in our world. The very concept of a liberal arts education might have expanded to include cosmic perspectives alongside traditional humanities. The space programs of major nations would have developed with different priorities and timelines. Rather than the Cold War space race focusing solely on human spaceflight, we might have seen earlier development of specialized orbital telescopes across the electromagnetic spectrum. The first space stations could have been designed as astronomical research platforms first, living quarters second. Lunar bases might have been established earlier as ideal locations for next-generation observatories, free from both atmospheric distortion and orbital debris. Cultural expressions would have absorbed this cosmic awareness in fascinating ways. Modern dance performances might have interpreted galactic collisions or stellar life cycles. Avant-garde composers could have created symphonies using actual stellar vibration data translated into sound. Even architecture might have reflected cosmic influences, with buildings designed to echo spiral galaxy structures or incorporate actual telescope observations into their designs. The philosophical implications of living with cosmic clarity for generations would have permeated society at every level. Where our timelines saw existential angst about humanity's small place in the universe, this alternate reality might have developed a more nuanced cosmic philosophy, one that balanced awareness of our physical smallness with appreciation for our unique capacity to understand the cosmos. Environmental ethics would have been framed not just in terms of preserving Earth, but of maintaining humanity's only vantage point for cosmic observation. As we reflect on this pivotal era in our thought experiment, we see a civilization standing at the threshold of profound new questions. The early Hubble's greatest legacy wouldn't have been the answers it provided, but the better questions it enabled humanity to ask. Having spent decades mapping the cosmic shoreline, scientists would now be preparing to wade deeper into the waters of understanding, equipped with tools, concepts, and perspectives that our timeline took far longer to develop. As our imagined timeline flows into the 1990s, the cumulative effect of half a century of space-based astronomy would have sparked nothing less than a full-blown cosmic renaissance, a flowering of scientific and cultural achievement comparable to history's great intellectual awakenings. This would not merely be an extension of previous discoveries, but a qualitative leap in humanity's relationship with the cosmos, enabled by the maturing of technologies and theories that had been gestating since those first grainy Hubble images arrived in the 1940s. The scientific frontier would have expanded in breathtaking new directions. With exoplanet studies now a mature field after 20 years of discoveries, astronomers might have developed the first atmospheric models of terrestrial worlds orbiting other stars. The search for biosignatures, chemical evidence of life, would have moved from speculative to systematic, with teams developing increasingly sophisticated spectral analysis techniques. Meanwhile, cosmologists could have been testing radical new theories about the multiverse or quantum gravity against decades of accumulated observational data, their work supported by advanced computer simulations running on machines that, in our timeline, wouldn't exist until decades later. The technology driving this renaissance would have been equally remarkable. Space telescopes in this era might have employed adaptive optics systems that could compensate for mirror imperfections in real time, their designs evolving from lessons learned through maintaining the original Hubble. Data transmission from orbit would have advanced from simple radio signals to laser-based optical communication, allowing the transfer of enormous image files that could be analyzed by artificial intelligence systems, primitive by our standards, but revolutionary for their time. Ground-based observatories wouldn't have disappeared, but rather evolved into specialized facilities working in tandem with their space-based counterparts, forming an integrated Earth-space observation network. The cultural impact of living with cosmic vision for 50 years would have reached new levels of sophistication. Where earlier generations had marveled at simple images of nebulae, citizens of this 1990s would have expected and received immersive experiences. Planetarium shows might have incorporated full-dome video projections based on actual telescope data, letting audiences fly through the Orion Nebula or witness galactic collisions from multiple angles. Virtual reality technology, still in its infancy in our 1990s, could have developed earlier and differently in this timeline, driven by the public's appetite for cosmic exploration rather than gaming applications. Education systems would have continued evolving to match this cosmic-aware world. Kindergarten students might have played with interactive orreries showing actual exoplanet systems, while high school science fairs could have featured projects analyzing real astronomical datasets. University graduate programs would have produced interdisciplinary scholars equally comfortable discussing quantum physics and galactic evolution, their research regularly making front-page news. The very concept of scientific literacy would have expanded to include basic cosmological understanding as an essential component of an educated citizenry. The space programs of the world's nations would have reflected this matured cosmic perspective. Rather than focusing solely on national prestige or military advantage, space agencies might have coordinated their efforts through international consortiums dedicated to specific scientific goals. The first permanent lunar base could have been established not as a political statement, but as the ideal location for next-generation telescopes, its construction benefiting from 50 years of experience maintaining instruments in space. Asteroid mining ventures might have moved from speculation to early implementation, driven by technologies developed to service space telescopes and the growing understanding of our solar system's resources. Philosophical and artistic engagement with the cosmos would have reached new levels of depth and nuance. Where earlier artistic interpretations had focused on the awe-inspiring beauty of cosmic imagery, this era might have produced works exploring more subtle themes, the thermodynamics of star formation expressed through dance, or the quantum behavior of particles interpreted in avant-garde musical compositions. Environmental art installations could have incorporated real-time data streams from space telescopes, creating ever-changing representations of our dynamic universe. The spiritual dimension of this cosmic awareness would have continued evolving as well. Traditional religious institutions might have developed sophisticated cosmic theologies that reconciled ancient beliefs with modern astronomical knowledge. New spiritual movements could have emerged that saw the universe itself as sacred, not through naive pantheism, but through deep engagement with the fundamental processes that govern cosmic evolution. Meditation practices might have incorporated guided visualizations of cosmic events, from the birth of stars to the collision of galaxies. As our imagined 1990s drew to a close, humanity would have stood on the threshold of a new era in cosmic understanding. The James Webb Space Telescope of our timeline, still decades in the future, might have been just one of many advanced observatories planned or already operating in this reality. Plans for interstellar probes based on decades of exoplanet studies could have moved from science fiction to serious engineering proposals. Most importantly, the cosmic perspective would have become so thoroughly integrated into human consciousness that looking upward with wonder would be as natural as breathing. This cosmic renaissance's most enduring legacy might have been the way it prepared humanity for challenges we've yet to face in our timeline. Climate change, resource limitations, and geopolitical tensions would all have been viewed through the lens of cosmic awareness, not as insurmountable problems, but as tests of whether a species that could comprehend the universe could also learn to care for its fragile home within it. The early Hubble's greatest gift 50 years on would have been this: not just the ability to see the cosmos, but the wisdom to understand our place within it. As our imagined timeline crosses into the new millennium, the cumulative weight of 60 years of unfiltered cosmic observation would have fundamentally rewired human consciousness. This wouldn't simply represent more scientific progress, but rather the emergence of what future historians might call the celestial enlightenment, a paradigm shift in our species' self-conception as profound as the Copernican revolution, yet unfolding gradually across generations rather than bursting forth in a single moment. The scientific breakthroughs of this era would have taken on a qualitatively different character, where early Hubble observations answered basic questions about what existed beyond our atmosphere. Turn-of-the-millennium astronomers would have been probing deeper mysteries of why the universe manifests as it does. The precise measurement of the cosmic microwave background might have revealed anomalies challenging standard cosmological models years earlier than in our timeline. Studies of distant supernovae could have uncovered dark energy's accelerating expansion of the universe before it even had a name. The first tentative evidence of higher dimensions or quantum foam might have emerged from painstaking analysis of light that had traveled billions of years across warped space-time. This period would likely have seen the maturation of entirely new scientific disciplines. Exoplanet climatology might have developed sophisticated models of atmospheric dynamics on worlds orbiting other stars. Archaeoastronomy could have emerged as a rigorous study of how galactic environments affect planetary system formation. Perhaps most intriguingly, cosmic evolution may have become a respected field studying universal development with the same rigor biologists applied to terrestrial life, searching for patterns in how simple hydrogen clouds evolve into complex galactic ecosystems. This cosmic enlightenment might have fostered a deeper sense of interconnectedness, not just between the nations of Earth, but with the entirety of the cosmos. The human species, forever changed by 50 years of unfiltered cosmic observation, might have been preparing for a cosmic coming of age, its destiny all along. The Hubble telescope's 70-year legacy would have transformed astronomy from a discipline of distant observation into something far more intimate, a mirror held up to our cosmic origins, our planetary fragility, and the fundamental interconnectedness of all things. This era might be remembered as when we stopped merely studying the universe and began consciously evolving with it. The scientific revelations of this period would have taken on a deeply philosophical dimension. Cosmologists, armed with generations of observational data, might have begun detecting subtle patterns in universal structure, large-scale symmetries or recurring mathematical relationships, suggesting deeper organizational principles beneath the apparent chaos. The study of exoplanet atmospheres could have advanced to the point of identifying not just biosignatures, but potential technosignatures, forcing us to confront profound questions about intelligence as a cosmic phenomenon. Meanwhile, quantum astrophysicists might have been exploring the eerie connections between quantum behavior on microscopic scales and the large-scale structure of the universe, bridging the gap between cosmic and quantum realities. The technology supporting these discoveries would have achieved near magical sophistication. Nanoscale actuators and telescope mirrors might have allowed real-time surface adjustments at the atomic level, canceling out even the most minute distortions. Distributed computing networks could have linked millions of personal devices into a vast cosmic brain, analyzing telescope data during idle processor cycles. Perhaps most remarkably, telescopes might have begun incorporating quantum entanglement principles to achieve resolutions theoretically impossible for conventional optics, not merely observing the universe, but subtly interacting with its fundamental fabric. Cultural expressions of cosmic consciousness would have evolved beyond representation into direct experience. Immersion pods might have allowed individuals to spend hours floating in sensory deprivation tanks, while neural interfaces created the visceral experience of traveling through cosmic phenomena, feeling the solar winds of a red giant, hearing the gravitational waves from colliding black holes, or sensing the space-time curvature near a neutron star. Architects could have designed entire buildings as cosmological metaphors, with atriums modeled after galactic cores and hallways tracing the spirals of accretion disks. Even fashion might have incorporated responsive materials that changed color and texture based on real-time cosmic ray flux or solar activity. Education would have fully embraced its role as the bridge between cosmic discovery and daily life. Kindergarten cosmic sandboxes might have used augmented reality to let children sculpt virtual nebulae with their hands while learning basic physics. High school students could have conducted original research using open access telescope time, their findings contributing to global databases. Universities might have offered degrees in applied cosmology, training specialists translate astronomical insights into solutions for energy, material science, and ecological challenges. The practical applications of cosmic knowledge would have reached into nearly every aspect of civilization. Quantum communication networks, inspired by studies of entanglement in distant quasars, might have made unhackable encryption ubiquitous. Medical imaging could have employed techniques derived from multispectral galactic surveys to detect illnesses at the molecular level. Urban agriculture might have utilized light frequency optimization strategies borrowed from studies on photosynthesis on exoplanets. Even our approach to aging and longevity could have been informed by research into stellar life cycles and cosmic timescales. Philosophically, humanity would have arrived at a new understanding of consciousness itself. The cosmic anthropic principle, the idea that universal constants seem perfectly tuned to allow our existence, might have evolved beyond theoretical discussion into a framework for daily living. People could have developed meditation practices focusing on recognizing the stardust within their own bodies, the supernovae that forged their atoms, the galactic processes that led to their moment of awareness. This cosmic mindfulness would have offered both profound humility and deep connection, the realization that we are simultaneously insignificant and integral to the universe's story. Religious and spiritual traditions would have continued their cosmic synthesis. The Vatican's Jesuit astronomers might have been joined by Buddhist cosmologists, Sufi astrophysicists, and indigenous star-knowers in a global interdisciplinary dialogue. Places of worship could have incorporated real-time celestial projections into their designs, aligning spiritual contemplation with cosmic events. New forms of ritual might have emerged, marking not just earthly cycles, but galactic ones, celebrations timed to the orbits of binary stars or the pulsations of distant quasars. The space infrastructure of this era would have been barely recognizable to mid-20th century observers. A permanent human presence on the moon might have supported kilometer-wide telescope arrays free from atmospheric interference. Solar-powered satellites could have formed an interplanetary communication network stretching to Mars and beyond. Perhaps most remarkably, the first experimental stellar lenses might have been deployed, using the sun's gravity as a natural telescope to magnify distant exoplanets to resolvable detail, a concept only theoretical in our timeline. As ordinary people went about their daily lives in this world, their baseline awareness would have been fundamentally different from ours. Children would have learned their elemental composition, oxygen forged in dying stars, iron from supernova explosions, alongside their ABCs. Workers might have paused during their day to check not just the weather forecast, but the cosmic one. Solar activity levels, meteor shower intensities, or particularly notable deep sky observations. Elderly individuals could have taken comfort in knowing their atoms would eventually rejoin the cosmic cycle, perhaps becoming part of new stars and worlds. This period's most profound legacy might have been the natural emergence of what we could call a cosmic ethic. An unforced, widespread recognition that caring for our planet and civilization is not just practical, but cosmically meaningful. Environmental stewardship would have been understood not as political ideology, but as the natural behavior of a conscious universe becoming aware of itself. International cooperation would have flown from the visceral understanding that all human conflicts occur on a single pale blue dot suspended in the cosmic dark. The early Hubble's ultimate gift, 70 decades on, would have been this: the quiet realization that in learning to see the universe clearly, we had finally learned to see ourselves. The Hubble telescope's 80-year legacy would have catalyzed something beyond scientific discovery, a fundamental shift in the relationship between consciousness and cosmos. This era might be remembered not for any single breakthrough, but for the dawning realization that the universe, through human eyes and instruments, was beginning to comprehend its own nature. The boundary between observer and observed would have grown porous as we came to understand ourselves as the universe's way of making meaning of itself. The scientific frontiers of this period would have blurred the lines between physics, philosophy, and metaphysics. Cosmologists might have been testing theories that the universe's fundamental constants could evolve over cosmic timescales, their research informed by ultra-deep field observations spanning light that had traveled most of the universe's existence. Quantum astronomers could have been conducting delicate experiments to determine whether consciousness played some role in cosmological scale quantum phenomena, not reviving discredited idealism, but exploring subtle interactions between observation and the observed at galactic distances. Meanwhile, exoplanet scientists might have identified dozens of worlds with complex atmospheric chemistry, suggesting not just life, but potentially technological civilizations, though still frustratingly beyond our ability to contact. The technology supporting these inquiries would have approached the realm of science fiction. Self-assembling telescope swarms might have formed kilometer-scale interferometers in deep space, their configurations constantly shifting like flocks of starlings to optimize observations. Quantum-entangled detectors could have allowed instantaneous correlation of measurements across astronomical distances, circumventing light speed delays. Perhaps most remarkably, astronomers might have begun experimenting with space-time itself as an optical medium, using precisely calibrated gravitational waves to lens distant objects in ways impossible with mere matter-based telescopes. Cultural expressions would have evolved beyond depicting the cosmos to embodying cosmic processes. Living museums might have used bioluminescent bacteria and carefully tuned ecosystems to model galactic evolution on walkable scales. Composers could have created works where the audience's brainwaves directly modulated the music in real time, mirroring how human observation affects quantum states. Architecture might have incorporated principles of fractal geometry and cosmic inflation, with buildings designed to grow and adapt like living universes. Even cuisine could have embraced cosmic themes, with molecular gastronomy creating edible nebulae and dessert clusters that mirrored galactic formations. Education systems would have fully embraced their role as conduits between cosmic wonder and practical understanding. Elementary schools might have employed cosmic playgrounds, where children's movements generated real-time simulations of gravitational interactions. University campuses could have featured observation immersion dorms, where students lived surrounded by real-time telescopic feeds from across the solar system. Elder hostel programs might have offered seniors the chance to contribute to citizen science projects, analyzing decades of archived Hubble data, their lifetime of pattern recognition skills applied to cosmic mysteries. The practical applications flowing from cosmic research would have transformed daily life in subtle but profound ways. Quantum communication networks inspired by entanglement studies might have made distance irrelevant for certain types of information transfer. Medical diagnostics could have employed multispectral analysis techniques derived from exoplanet atmosphere studies to detect diseases at their earliest molecular beginnings. Urban planning might have drawn inspiration from the efficient energy flows of galactic ecosystems, creating cities that function more like living organisms than mechanical grids. Philosophically, humanity would have arrived at a new understanding of time's nature. With routine observation of cosmic events unfolding over billions of years, the distinction between past, present, and future would have grown fluid in the cultural imagination. People might have developed what could be called temporal pluralism, the ability to hold multiple timescales in mind simultaneously, from the quantum flicker to the galactic rotation. This temporal flexibility could have influenced everything from economic planning to personal psychology, helping civilizations make decisions benefiting not just the next quarter or election cycle, but the next millennium. Religious and spiritual traditions would have completed their graceful merger with cosmic understanding. The Vatican's observatory might have been joined by Buddhist quantum cosmology centers and indigenous stellar navigation institutes in a global network of wisdom traditions. Places of worship could have incorporated real-time cosmic data streams into their rituals, aligning ceremonies with particularly significant astronomical events. New forms of meditation might have emerged, focusing on experiencing one's body as a temporary constellation of ancient stardust, soon to return to the cosmic cycle. The space infrastructure of this era would have made the early Hubble look like a child's toy. A permanent human presence might have extended to Mars, with scientists living in biodomes while maintaining arrays of telescopes free from Earth's atmospheric distortion. Solar system-wide laser communication networks could have allowed real-time collaboration between researchers across planets. Perhaps most remarkably, the first experimental stellar engines, hypothetical megastructures for gently steering entire solar systems, might have been in early planning stages, their designs informed by centuries of precise astrometric measurements. As ordinary people went about their lives in this world, their baseline consciousness would have been fundamentally different from anything we know today. Morning routines might have included checking not just weather and news, but the current cosmic background radiation levels or nearby supernova events. Lunchtime conversations could have casually referenced new evidence about the universe's topology or debated the philosophical implications of recent exoplanet discoveries. Evening entertainment might have included family cosmic visioning sessions where shared meditation created collective visualizations of interstellar journeys. This era's most profound legacy would have been the natural emergence of what we might call cosmic compassion, the unforced understanding that all life shares a common stellar ancestry and cosmic destiny. Environmental stewardship would have been practiced not from fear or obligation, but as the natural expression of a universe tending to its own awakening. Political conflicts would have seemed absurd against the cosmic backdrop, like ants fighting over a leaf while floating in an infinite ocean. The early Hubble's ultimate gift, 80 decades on, would have been this quiet revolution in consciousness, the realization that in our deepest nature, we are the universe, experiencing itself with wonder, curiosity, and increasingly with love. As our thought experiment draws to a close, we arrive at a quiet revelation. The true significance of imagining an early Hubble telescope lies not in the altered timeline of technological achievements, but in recognizing how profoundly our cosmic perspective shapes the human journey. Across these 12 messages, we've wandered through nearly a century of what-ifs, watching how a single instrument's premature birth might have rewritten our relationship with the universe. Yet the most enduring lesson isn't about altered history, it's about the timeless human capacity for wonder that such a telescope would have served. The hypothetical astronomers in our alternate 1940s, peering at those first grainy space-taken plates, stood at the same existential threshold we face today, just with earlier clarity. Whether in 1945 or 2045, the cosmic revelations follow a similar arc. First comes the shock of scale, then the humbling awareness of our smallness, followed eventually by the dawning realization that our ability to comprehend the vastness
constitutes its own miracle. The dates change, but the epiphany remains. We are stardust become conscious, the universe awakening to contemplate itself. All the technological marvels we've imagined, the advanced telescopes, the lunar observatories, the quantum entangled detectors, were never really about the machines themselves. They were manifestations of something more fundamental, our irreducible need to seek, to understand, to connect. The hypothetical early Hubble simply allowed this yearning to express itself sooner and more vividly, like giving a vocabulary to someone who already felt profound emotions but lacked words. The cultural transformations we traced, the cosmic-inspired art, the spiritually infused science, the education systems nurturing cosmic literacy, all point toward a single truth. How we see the universe shapes how we see ourselves. That fragile blue marble image of 1972 didn't merely fuel environmentalism, it rendered a truth poets had long sensed visible. Our imagined early Hubble would have provided this perspective decades sooner, yes, but the deeper message remains identical across timelines. We're all crew on the same planetary lifeboat, adrift in a magnificently indifferent cosmos that we're somehow privileged to witness. Perhaps the most poignant realization from this journey is that all telescopes, whether hypothetical or real, are ultimately time machines. The Hubble we know and the one we imagined both shared this power. They let photons that have traveled for millennia finally find rest on a detector or photographic plate, completing journeys begun before human civilization existed. In this sense, every astronomical image is a fragmentary message from the past, and every observer becomes a kind of temporal translator. The dates when we built our telescopes matter less than our willingness to receive these ancient light letters with humility and care. As we leave this alternate timeline behind, we might carry forward one essential question. Does seeing the universe more clearly necessarily make us wiser? Our thought experiments suggested it could, showing how earlier cosmic awareness might have softened nationalism, accelerated environmentalism, and fostered global collaboration. But technology alone never guarantees enlightenment. The real work, in any century, in any timeline, remains the same. Translating cosmic perspective into earthly compassion, letting the view from above inform how we live below. The Hubble we know, launched in 1990s, and the one we imagined in the 1940s, share the same ultimate purpose. Not just to reveal the universe's grandeur, but to help us recognize our own. Whether through early black and white plates or modern digital images, the message remains constant. We inhabit a small world in an ancient cosmos, and our significance derives not from our size or duration, but from our capacity to wonder, to question, and to care. So let us conclude not with speculation about what might have been, but with gratitude for what is. A universe vast enough to humble us, mysterious enough to challenge us, and beautiful enough to captivate us across all possible timelines. The telescopes we build, whether past, present, or future, are simply tools to help us remember what we've always sensed, but often forget, that the night sky isn't just above us, but within us, that every atom in our bodies was forged in ancient stars, and in looking outward, we're also gazing inward. The conversation between humanity and the cosmos has no final message, no concluding chapter, only pauses between questions as we prepare to listen anew. Wherever and whenever we build our telescopes, the universe keeps whispering its secrets across the light years, patient as the stars themselves, waiting for us to develop eyes clear enough to see, minds open enough to understand, and hearts wise enough to cherish what we learn. Thank you for joining this journey through cosmic imagination. May your sleep be ever deepening like the possibilities of space and technology is.